Chapter 7, Chemical Reactions. I'm Miss Varney.
And I'm Miss Sandary.
I would pause the video here and look up these words and their definitions in the back of your book.
All right. Now that you know all the vocabulary words, I want to do a quick slide on reactants and products to make sure you remember, and if you don't remember, or if this is new to you, pay attention. Reactants are on the left side of the chemical equation. Products are on the right side of the chemical equation. So if we take a look at this example down here, on the left-hand side, we have 2 magnesium plus 2 oxygen. Notice these 2's are different. We've got a 2 right here, which we call a coefficient, and we also have a 2 here, which we call a subscript. Sub means below, so it makes sense that we call it a subscript. So these are our reactants on the left side. On the right-hand side of the arrow, remember the arrow means yields. So this right-hand side, these are our products. Notice we only have one. We have 2 magnesium oxides. Remember, this 2 is a coefficient. And this 2 applies to both the magnesium and the oxygen. All right, how molecules are symbolized. First off, we have the Cl2. Notice this 2 is a subscript. Now, a subscript 2 means that these chlorines are actually bonded together. Whereas with 2Cl, this 2, once again, is a coefficient. Notice we have 2 separate chlorines not bonded together. Now, if you take a look at this third example, 2Cl2, it's a little bit different. We have 2 groups of Cl2. So we've got Cl2, which is this. However, we have 2 groups of it. So we end up having 2 separate Cl2 molecules.
So what you're saying is the coefficient indicates the number of groups.
Correct.
Okay.
All right, moving on. Picturing chemical formulas. Molecules may also have brackets or parentheses to indicate numbers of atoms. So when we take a look at these parentheses, notice oxygen and hydrogen are included in the parentheses. Calcium is not included in the parentheses. So when we take a look at this 2 subscript, this 2 applies only to the members of the parentheses. So calcium does not, there are not 2 calciums, there are only 2 oxygens and 2 hydrogens. This is a picture of what this would actually look like. So we've got 1 calcium and 2 hydroxide groups. Hydroxide is just OH. So we've got 2 groups of those because this 2 right here says that we need to have 2 of these OHs. All right, practice problems. So how many of each atom are in the following? You should be able to answer all 3 of these. First one, NaOH, we have just 1 sodium, 1 oxygen, 1 hydrogen. Notice there are no coefficients and there are no subscripts anywhere. So there should be 1 of each. There's your answers down below. The second one, calcium. This is the one that we just did together on the previous slide. So you should already know. Just 1 calcium, and then we have 2 oxygens and 2 hydrogens. The last one is definitely the trickiest. If we take a look at this 3, if you remember this distributive property from your algebra class, this 3 is going to distribute all the way through to all 3 of these atoms. So we're going to have 3 calciums because of this 3. This 3 is also going to influence the oxygen and the hydrogen. Notice on the other side we've got a 2 right here. So 3 times 2 will give you 6. So we actually have 6 oxygen and 6 hydrogen. So if you see the answer right here, that should help explain it. All right, next slide. The law of conservation of mass. It states that matter can neither be created nor destroyed. Sort of sounds like one of the 10 Commandments, which in science maybe it is. The big thing to take away from this is that atoms cannot just appear out of nowhere, nor can they just disappear. So when you burn a fire in your backyard, if you have a bonfire, when you burn that log, the log does not disappear. It's just converted into something else, such as ashes and smoke and heat, stuff like that. So same goes for a chemical equation. These chemicals are rearranged. They are not, they do not disappear. They do not appear out of nowhere. So when we balance an equation, we have to have the same number of atoms on both sides of the chemical equation. All right, so here's a practice problem, magnesium and oxygen. So, quick review, remember reactants are on the left-hand side of the equation, so these are our reactants. Over here is our product. So, if we take a look here, usually I draw a line between the reactants and the products. If we take a look, we only have one magnesium because we do not have a coefficient, which would be here, and we do not have any subscripts. Oxygen on this side. There are two oxygens because we have a subscript right here. On the product side, we have one magnesium because there's no coefficient and there's no subscript. And then oxygen, we also only have one. If you take a look, this is definitely not balanced. The reason is because we have two oxygens on the reactant side, which is the left-hand side, and only one oxygen on the product side. So what we have to do is we have to figure out a way to balance both sides of the equation. So what we need to do is we have to add a coefficient. One of the big rules about balancing equations is you can only add coefficients, not subscripts. So go ahead and write that down. Only add coefficients, do not add subscripts. So as convenient as it would be to just, how about I just put a 2 there? You cannot do that. That would be nice, but we can't. We can only add coefficients. So when we add this coefficient to the front of magnesium oxide, this also changes the number of magnesium in the equation. So it goes from 1 to 2. And it also distributes through and influences the oxygen. So oxygen changes from 1 to 2 as well. Now, if we recap back here, you'll notice that magnesium is suddenly not agreeing on the reactant versus product side. Oxygen is good. Oxygen is agreeing with 2 and 2. So we actually have to add one more coefficient to this side. We're going to add a 2 to this side so that magnesium has 2 on both the reactant and product side, and same goes for oxygen. So this is what it would look like. And here's the tallies down below. All right, so how to balance accurately. If we take a look here, this was our original equation. This is our new equation. This is the correct way to write it. There are several incorrect ways to write it as well, so we're going to go through that. All right, so first one, magnesium plus 1/2 oxygen yields magnesium oxide. If you would like to try to do this, that's not going to actually work as it would turn out. You cannot just throw any kind of fraction out front. Next one, Mg2 plus O2 yields 2 MgO. This is also incorrect. The reason why it's incorrect is because we cannot add subscripts. All we can add are coefficients. So that's why this one is incorrect. We cannot do that. All right, and then the last one is also considered incorrect. The reason for that is because if you remember simplifying or reducing fractions back in grade school, it's the same idea. We have 4 magnesium plus 2 oxygen yields 4 magnesium oxide. If we were to take this whole thing and divide by 2, we could actually simplify this down. And actually, when we simplify it, it would look exactly like the original. So make sure that when you balance equations, it's okay if you start out with this, but make sure that you know you can divide it by 2 and simplify it to the best of your ability. All right, so here's some practice problems balancing the following. Go ahead and pause in a minute to do these.
A moment to pause the video and check with your answers, see where you may have gone wrong. We'll be looking for the work to see the 2 columns as you went through and balanced each equation, so make sure you have the work in your notebook as well.
We are moving on to synthesis reactions. The word synthesis, if you've heard it before, it means when you are combining things together. So if you were to synthesize something, you would compile several things together to create one product. So, chemical reaction in which 2 or more substances react to yield, remember yield is that arrow sign, a single product. So our example here, A plus B yields, that's the arrow, AB. So if we put actual chemicals in the equation, this P4 represents our A, plus I2, that's our B, yields PI3, that's our AB being combined together. Notice also this is not a balanced chemical equation, so if you wanted to, you could balance it right now. Next one, decomposition. So when something decomposes, that means it's being broken down. So a chemical reaction that is classified as a decomposition reaction occurs when you have a single compound breaking down into 2 or more elements or new compounds. So we start out with a single compound, end up with 2 new ones. So if we take a look, this is actually the reverse of our synthesis reaction. We start with AB, so we start with a compound. At the end of the reaction on our product side, we actually have A plus B. All right. If we take a look at this example, we start with one compound, KClO3. At the end of the reaction, we end up with KCl plus O2. So this is our AB. Here's our A. Here is our B. All right, single replacement reactions. This reaction occurs when you have atoms of one element being replaced by atoms of another element in a compound. So if we take a look at our example, we're introducing a new variable. So we started with just A and B. We're adding in an X. So we start out, A is by itself at the reactant side of the equation. However, if we take a look at the end of the equation, A is now being joined with X, whereas B started with X, but then at the end of the equation, B is by itself. That's why we call it a single replacement, because we're having this X move once from one chemical to another. So if we take a look at an example of this, we have magnesium plus hydrochloric acid yields magnesium chloride plus hydrogen. So if we take a look over here, magnesium is by itself, so we're going to call magnesium A because it's doing the same thing as what A is doing. At the end of the equation, remember, A is joined by X. If we take a look at magnesium, guess what? It is joined with chlorine. So this chlorine is going to be our X. Hydrogen will be our B. So B starts with being bonded to something, but at the end of the equation, hydrogen is going to end up being by itself. I know it says H2, but hydrogen isn't bonded with any other type of atom, just with itself.